In this video, we are going to go over sections 4.4 and 6.3. This is a method of undetermined coefficients. So to start off, we are building our way up. Know that we did before this, we did homogeneous linear ODEs. That's when this side was 0. But we're going to focus on non-homogeneous and only some special cases in this video. So as long as the g of x is 0, we have a method for it. We can find a solution to that. But if it's not 0, we got to come up with a different way. Now, there was a principle we talked about before this one that talked about if I have a general solution to the corresponding homogeneous, that means if I were to make this 0, then the answer to that is y sub c. If I make that 0. Y sub p is a particular solution, just one of them, a particular solution to the DE actually given. So y sub c is the solution to the corresponding homogeneous. That means if g of x was 0. And then y sub p is just a particular solution. So as long as we can find both, we have an answer. So right now we can do this. We can find y sub c, right, which is the general solution to the corresponding homogeneous. If I were to let g of x equal 0, we can do that. In this video, we are going to work on finding a particular solution to a non-homogeneous, so given that g of x is not 0. Now, we did this at the very beginning. Notice that the only thing being done to the function y here are either we're multiplying by it or we're multiplying by its derivatives, and we want to end up with the right side. We did something very early on, and we talked about this in the homogeneous case of there was a function where e to the x was our solution, and it made sense because when I take the derivative of e to the x, I get e to the x. I land back in the e to the x. There are other functions like this as well that rotate or give us something predictable to figure out our answers. What I'm saying is I can maybe eyeball this thing as long as this function that's over here, g of x, as long as that function is something nice and pretty, then I can probably eyeball it and figure it out. Let's talk about what that means. All right, so I have a little chart down here. The right-handed side, if it was a polynomial, that is a quadratic in this case, but any kind of polynomial, our guess of a solution would be another polynomial, and this is because when I take a derivative of a polynomial, it's called closed under derivatives. I take the derivative of a polynomial, I get a polynomial. So it makes sense for us to try to eyeball it and make some kind of guess to make the left side do all the derivatives, and we can multiply by things and try to make it end up being the g of x. It's kind of like what you did in algebra where you do like, okay, 2x plus 5 is equal to 15. And you could solve, we have methods, and we're going to talk about methods to solve these things maybe without having to eyeball. But you could sit and wonder, okay, what times 2 plus 5 is 15? That's all we're doing, is we're going to make an educated guess, and then we're going to go with it, and there's a method we can do. So if it's a polynomial, we can make an educated guess for a solution that is a polynomial. It's not going to have the same a, b, and c. That's why I did m, n, and p. I didn't do o because it looks like a 0. We also have, if it's exponential on the right side, then our guess should be exponential. Notice the constant out front is different, but the constant with the x will be the same. The last one that's not as pretty is if I have a cosine or a sine. And we should have seen this when we were doing integration by parts, and then there was like tabulature integration. I don't like using tabulature integration, but we can. And mainly in tabulature integration, we're looking for things that either go away or repeat. Well, cosine and sine, just like if I take a derivative of cosine, I get negative sine. Take derivative of negative sine, I get negative cosine. Take derivative of negative cosine, I get a sine. Like it just flips back and forth. So all three of these functions, the top one a polynomial, I take the derivative, I get a polynomial. The middle one, we know that derivative of e to the x is e to the x. We land back in there. And then sines and cosines also land back on sines and cosines. These are the only three types that we can do. We can actually do sums as well, so if we add two of them together, and we can do products. All right, so let's take a look at example 1. So it says, make an educated guess for each of the following non-homogeneous linear ODEs when g of x is the following. All right, so this is just saying, looking at this equation that we have at the very top here, they're saying that g of x, this thing right here, is equal to that, x squared minus e to the 3x. And they just wanted us to come up with a guess. So my guess for this one, and we'll call this the particular solution, here's my guess, is, okay, I see an x squared, so that tells me my guess should be a polynomial. So I'm going to do ax squared plus bx plus c. I pick whatever. If it's a quadratic, I make a quadratic. If it was linear, I make linear. If it was cubic, I would make a cubic. Now I'm going to add this to, okay, I have this e to the 3x, so this tells me to use, okay, I'm going to use d e to the 3x. I don't need a negative d because the d could be negative itself. So I don't need to, because of this minus, I don't need to put a minus in between. That is my answer, possibly. It's a guess. And we're going to see that we can make these things kind of work out for us. Right, the second one, notice we have two parts, two things being multiplied. I have this linear function times this exponential. So my guess is from the exponential, I get ax plus b. That's a linear guess, because negative 3x is linear, times, and then I got to use c e to the 2x. So there's my guess for that. I just multiply them together, just like my two problems are multiplied to begin with. Now notice here on c, we have these two being multiplied. We also have these two being multiplied, so we actually have to run the whole thing for each part. So focusing only on this part. So the guess for the x is ax plus b times, okay, the sign gets me a cosine 2x plus b sine 2x, right? Plus, okay, I used, oh, we don't want to use these same letters, by the way. C, D, we don't know they're true. All right, and then plus, okay, then I get ex plus f. That's, oops. It's got to be the linear, not the linear anymore, we're right here. So it's plus e to the, I don't want to use e, let's use just f, we'll skip e. F e to the negative x times its cosine guess. So this one's going to be efg sine x plus h cosine x. You can use whatever letters you want as long as they're not repeating when you use them again. So there's my guess. These problems get nasty, and you'll know after you see some other examples 2 and 3 that these guesses are, C would be horrendous to try to figure out. So let's work on finding some particular solutions to these problems. So let's take a look at example 2. All right, so we are going to make an educated guess here. So my educated guess, since the right side, so since g of x is equal to 3, and we need a t here. G of t equals 3t. Then our guess is, okay, so y sub p equals ax, or at plus b. That's my guess. Okay, once I get my guess, when we're doing guessed in this section, it feels weird because we're going to be like, oh, that's our solution, and then we're going to use that guess to find an actual solution. So doing this, we need, if I'm going to plug into here, I need the function itself. These are p's, yp prime, yp double prime. I need each one of those. So I got to find y prime, which is just going to be a. And then we also have y double prime, which a is just a constant, so it's 0. Right? I then now plug everything into here. So plugging that in, my second derivative is 0, plus 3 times my first derivative, which is a, plus 2 times my second derivative, which is at plus b. And we want that to work out where we get 3t. All right, I do all my distributing, 3a plus 2at plus 2b equals 3t. And now I'm going to put a 0 over here, and we can make this kind of look like over here. So I'm going to put an underline. That's going to be my 2at. Okay, so I know 2a has to be that number. And then plus my other is a 3a plus 2b. I put those together, and that has to equal the 0. So notice what's underlined here. These two parts have to be equal because they're a number in front of t. And then these are the numbers that are not in front of t or t squared or anything like that. So I know those have to be equal. So from here, I can write a system of equations. I know 2a must be 3. I also know that 3a plus 2b must be 0. Right? This tells me that a is 3 over 2. And then I plug that into the other equation to get b. So I got 3 times 3 over 2 plus 2b equals 0. So we get 2b equals negative 9 over 2. So b equals negative 9 over 4. So that is my particular solution. So y sub p, right? We look at our guess. Our guess was this. And I found an a and b. So a is 3 halves. So we got 3 halves t minus 9 over 4. So we took a guess, and then we could tell the way we were working out what it was going to work out where a is that and b is that. If we can't find a solution, that probably means there is not one. Okay, so let's take off on this next one. So I'm going to give you 3 solutions where they all have 3 different types. I think the third one is going to be a bit weird, but we'll take a look at it. So find a particular solution to that. So my guess, so since, I'll write this out for notes, since g of x equals 10 e to the 3t, then our guess is y sub p equals a e to the 3t, which tells me my derivative is 3a e to the 3t. And then yp double prime is 9a e to the 3t. So there are our guesses. We're going to plug this in now into our dE at the top. I got 9a e to the 3t plus 3 times the second one, 3a e to the 3t, plus 2 times our guess. And we're going to make this happen by setting it equal to 10 e to the 3t. All right, so I get 9a. I'm going to make a jump here. I get 20a e to the 3t. And a way you could think about this is you could think, okay, I just need things in front of e to the 3t to be equal, or you could divide by e to the 3t, which it gets us 20a equals 10, which means a equals 1/2. So I have my particular solution. This one's a little faster. 1/2 e to the 3t. So as long as they're these nice pretty guesses, we're set. All right, let's take a look at our fourth example here. All right, this one worked out in class. It was pretty gross. So this will be maybe a bit different. So what we need to do for our guess is we have a sign. So since g of x is equal to sine of t, then our particular solution we are going to guess is a sine t plus b cosine t. All right, so I can take my derivatives now. First derivative is a cosine t minus b sine t. And then my second derivative of my guess is going to be negative a sine t minus b cosine t. All right, now plugging this back in. All right, so we get the second derivative. So negative a sine t minus b cosine t. That's the second derivative. Plus 3 times the first derivative, a cosine t minus b sine t. And then plus 2 times our guess, which is a sine t plus b cosine t. And we want all that to end up to just be a sign. So looking at this giant equation, we have sines and cosines. Regardless of what a and b, those sines and cosines are still going to remain sines and cosines. But I want to end up over here with just my sine. So I'm only going to pick up the sines. I don't care about the cosines because I don't get a cosine. I want the cosine on the, for now I don't care about it. So right now I have that, so I get negative a sine t minus 3b sine t plus 2a sine t, and that equals 1 sine t. So what that tells us, this implies that negative a minus 3b plus 2a equals 1. Right? That gets me a minus 3b equals 1. So I'm going to highlight this. We're going to use it here in a moment. Okay, now I'm going to use the cosines to create an equation. So let's do that in a different color. B. So I got this and that. So I got all three of those. Negative b cosine of t plus 3a cosine of t plus 2a sine of t. Oh, I need a cosine. Don't know what I was picking up. That third one is that b cosine of t times 2. So 2b cosine t. And this equals the 0 in front of cosine because there is not one there. All right, this implies, all right, there is no cosine. I'll put it there though. That negative b plus 3a plus 2b is equal to 0, which tells me b, let's keep it a and b in order, I guess. 3a plus b equals 0. All right, there's a couple things you could do here. Here's my two equations. Now I have two equations and two unknowns. So I just need to solve those. I'm going to write those down here. My system is a minus 3b equals 1, and 3a plus b equals 0. Right, this gets me that b is equal to negative 3a, and now I'm going to plug that into my first equation. So I get a minus 3 times negative 3a, I just replaced b, equals 1. So a plus 9a equals 1. So I get 10a equals 1, which means a equals 1/10. Now I can use this and that, and I get b equals negative 3 times 1 over 10, which tells us that's negative 3/10. So we have a particular solution now. So particular, a is 1/10, so it's 1/10 sine of t minus 3/10 cosine of t. So again, you just identify what's there. Once you identify what is there, then you just line things up, come up with two systems of equations, and solve that system. Good old algebra coming back at us. All right, so